So the mass of 3 kilogram rests on a surface of a smooth plane. So if we're going to start with a diagram inclined 45 degrees to the horizontal, the mass is attached to a cable which passes up the plane and passes over smooth pulley at the top. So we have the 3 kilogram mass which is on a smooth plane and passes over a smooth pulley, and the cable carries a mass of 1 kilogram. So if there is a 1 kilogram mass hanging from the pulley, we want to include the weight, so the weight must be 1 g newtons in this case. And we know there is a mass of 3 kilograms on the smooth plane. If we include the weight, it's 3 g newtons. We would like to include all the forces in there, so we start with normal reaction force, which must be perpendicular to inclined plane. And as we know from our question, there is a force of P newtons acting horizontally, so on the 3 kilogram mass, which is going to keep the whole system in equilibrium. So if we start now to decompose the weight in a horizontal and vertical component, the angle is 45 degrees. The vertical component must be 3g cos 45, and the horizontal component must be 3g sine 45. We want to include all the forces. And we do need as well to decompose the P Newton force into horizontal and vertical component. The angle must be as well 45 degrees, and the vertical component must be P sine 45, and the horizontal component is P cos 45. So what we would like to do, we would like to find the magnitude of particle P, and is in equilibrium therefore. So when we resolve horizontally and vertically, that means there is no acceleration because the P Newton force is going to keep everything in equilibrium. So if we start as well to include the tension for 1 kilogram mass as well as the tension in the string up the slope, and if we would like to work out the tension using the 1 kilogram mass, so we take positive direction and we apply the Newton's second law, and we can write down T minus 1g equal to 0 because is in equilibrium. We want to rearrange and work out the value of T. T must be 1g newtons in this case, which also we can write down 9.8. So once we have the tension, therefore we can as well look and resolve. We are updating our diagram. That tension is 9.8, as well as we can resolve parallel to inclined plane, so because we want to work out the magnitude of our force P. So if we resolve parallel to inclined plane, make sure you take positive direction. We start with a force going in that direction. So we start with P cos 45, that's the force, the horizontal force going in a positive direction. And we would like to add the tension, which is, we worked out, is 9.8. And as well, we need to minus the opposite force in that case, which is 3g sine 45. We want to rearrange and we want to work out the value of P. So we divide everything by cos 45 and we use the calculator, type it in, work out the value of P, and give your answer in newtons as well. So we have worked out the value of P for part A. For part B, we would like to find the normal reaction between the mass and the plane. So for inclined plane, we want to work out the normal reaction force. So we want to resolve perpendicular to the inclined plane. And again, if we take positive direction in this case, and we start with the forces acting, that in that direction we apply the Newton's second law. So we are going to write down R minus P sine 45 and minus 3g cos 45, make it equal to 0 again. Everything is in equilibrium. You want to rearrange and work out the normal reaction force in this case. Give your answer to 3 significant figures. Thank you.